I've jumped into my AWS account now so that I can start by showing you an example of what I've deployed with the templates. Here is one of the CloudFormation templates that I've run. If we take a look at the template itself, and if we scroll down, we can see some sample code here, and I can see my material text extraction flow. It will pull data from the Zero Material Text Extractor in SAP and will deploy as active. So once it's deployed, there will be nothing else for me to do. It's scheduled and it's going to run incrementally, so it will only bring through new and changed records from SAP. It's scheduled to run daily and at the start time that I define in my parameters. The connection name will be my SAP system connection, and the OData path will be the specific gateway path from my SAP environment. The data will land in my chosen S3 bucket, in this case also parameterized, and will be prefixed at a daily level. I'll extract all source fields from the extractor. That's my flow, and a flow is defined for each source. If I now jump into my resources, you can see that this CloudFormation template has deployed many different flows. So now let's take a look at one of those deployed flows. I'm going to jump into Amazon AppFlow. If we search for our new flow here, we can see what the CloudFormation template has deployed. We can see the active flow with a successful run status. If I go in and view the details, I can see the run history, and the last execution has 0 records, so no changes have been processed. But I can flick back to its first run and see that all of my records have come across. And since then, it's now been running at the scheduled time each day. We can also see the details of the S3 bucket where the data has landed. So now let's go and have a look at the Glue data catalog entry for this data. Great. Here we can see the same S3 location referenced and the table definition, including descriptive details in the comments that have come from the OData metadata. Let's take a look at a more complicated data source, a transactional data source for purchase order items. Here we can see many more fields and different data types that have been defined. Our Lambda function has done all of this for us automatically. So I have done the required setup in my SAP system, executed some templated CloudFormation scripts, and now I have the SAP data landed. The flows will automatically load ongoing changes to that data for me. It's catalogued that data in Glue in an understandable format, which means I can immediately consume that data in Athena now. So let me show you. Here is my catalogue data, and I can simply query it. First, my material text that we just saw in Glue. Then, my purchase order items. Maybe add some additional SQL commands. Excellent. But I want to have this data modeled. I want to be able to query pre-built modeled data, and I want to be able to query changes in my data over time and understand the impact of these changes, such as purchasing quantities increasing on a document and the impact on delivery times. So let's go and take a look at what has been created for me in Redshift. Here I have my Redshift cluster and the schemas and table definitions that were automatically deployed by that Lambda function. In the staging tables, which are used as part of the loading process, we see its technical field names. Once we move into the data mart schema, we see the English names, making it much easier to query data. If I scroll down, you'll also notice that we have additional date fields, such as a valid from, end, and a current flag. This means these data mart tables will store all of the historical changes in data, as well as the current view. This is great for driving deeper insights. If I move up to the architected data mart layer, I can also see some views that have been deployed. These are materialized views and give us that modeled data for consumption. When I view the view definition of my purchase order analysis, we can see it's a pre-built join across multiple tables with some built-in logic. This helps alleviate that heavy lifting involved with understanding the SAP data models, as well as a simplified experience when we consume it directly in QuickSight. Now, all of this has been provided by the accelerators. But what if I want to do some of my own data modeling? I did mention Amazon Q earlier, so let's see how it could help us here. I'll create a notebook and start to ask the generative SQL to help me. Who is my top performing supplier? Great, I have a SQL returned that I can add to my notebook and execute. This gives me my top supplier ever. So let's ask for just 1 year of data. In the same query, restrict for fiscal year 2020. Perfect. I can see the supplier ID, but I'd like to know their name by joining this to the master data tables. In the same query, add a join to vendor text for supplier name. Now, as you can see, this query isn't quite right and it's errored. Just like Q can help me with errors, I'm going to get it to fix the query with these details. I can already see myself it's because the supplier field isn't qualified. I'll pass it the error and it remediates the query. Handy. Great, so now I know their name. I'd also like to understand the materials that they're selling, and so on. In the same query, add material and join to material text description. Add to the same query the material number. Behind the scenes, Amazon Q Generative SQL uses a large language model, an LLM, and Amazon Bedrock to generate the SQL query. We use different techniques, such as prompt engineering and retrieval augmented generation, or RAG, to query the model based on your context, the database you're connected to, the schema you're working on, your query history, and, optionally, the query history of other users connected to that same endpoint. The system also remembers previous questions, as I've shown you. You can ask it to refine those previously generated queries. Top supplier materials by invoice amount. I can even visualize the results in here if I'd like. Now, let's take a look at consuming that same data in Amazon QuickSight and use the Gen BI features there. Here in QuickSight, I have a dataset connection. This points to the underlying materialized view we saw earlier that had been created in Redshift for us. From that, I've created a topic. Let's do a quick review. Now, it hasn't included all the fields that I'd like to be there. I'd like plant to be there as well, so I'm going to add these fields. And as you can see, it's suggested synonym names for other fields. So I'm going to let it know that my business users talk about the warehouse, and in the SAP system terms, that is the plant. This is a simple step to ensure any terms specific to your business are interpreted correctly. From here, we can ask questions of our data and confirm the responses. Value by warehouse. This is exactly what our users will be able to utilise when building out analysis and dashboards. Dashboard authoring capabilities empower business analysts to swiftly build, uncover, and share valuable insights using natural language prompts. And with the pre-modeled data provided, this can be straight away. Now, let's jump to a dashboard I published earlier and take a quick look at some more of the Gen BI features available. In here, a business user may want to get Gen AI to create a summary of their dashboard visualizations. Or, my favourite, build a story based on these visualizations. Let's ask Q to write us a report on supplier performance and consolidation for purchasing. Write a summary of supplier performance over time and where we could consolidate purchasing of certain materials. Here's the result, and I think it's very impressive. I can see it is highlighting our dependencies on a few large suppliers and the diversity of materials. Wow, I've shown you a lot, but remember the accelerators will help you to deploy almost everything that you have seen today with provided templates so that you and your business can get onto driving those insights at speed. Of course, through the use of natural language and with Amazon Q. I'm going to send you back to Pete to close off. Thanks, Pete.